Okay, we're going to look at section 1.5, applications of linear equations and modeling. This is just about when we use linear equations, what kinds of situations in the real world are situations where we would need a linear equation and where we would use a linear equation. So that's what we're going to do. You might want to take a look at the point slope formula in your book. I'm not going to ask you to memorize that or use it. But it could be on the ACT or SAT, so you might want to take a look at that in this section. But anytime you want to find the equation of a line, I would just ask you to use y equals mx plus b. So you already know how to find the equation of a line that passes through a point and has a certain slope because we talked about it in the last video. So we'll move on from there. Write an equation of a line passing through these 2 points. Y equals mx plus b, that is the equation of a line. And to find m, the slope, you just use the slope formula, which is the difference in the y's over the difference in the x's. And that is going to be 8 over negative 5. So the slope of this line that goes through these 2 points is going to be negative 8/5. So we're going to put that in for m. So we'll have y equals negative 8/5 x plus b. And now to find b, we can just plug in one of the points that we have. I'm going to use the second point because it's got smaller numbers and it just looks easier. So I'll put in 2 for y and then negative 8/5. And for x, I'll put negative 1. And there's b. So I'm going to solve for b. So that'll be 2 equals 8/5 plus b. I'll subtract 8/5 on both sides. 2 is 10/5 minus 8/5 is 2/5, and that's b. So the equation of our line, we have our m, we have our b. So our m is negative 8/5. Y equals mx plus b is 2/5. So we've done it. If m sub 1 and m sub 2 represent the slopes of 2 non-vertical parallel lines, then m sub 1 is equal to m sub 2. So parallel lines have the same slope. That's basically all that's telling you. If m sub 1 and m sub 2 represent the slopes of 2 non-vertical perpendicular lines, then m sub 1 equals negative 1 over m sub 2, or equivalently, m1 times m2 is equal to negative 1. So parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. So we use that fact to do this kind of problem here, where they tell you or ask you to write an equation of a line passing through the point 2, negative 3, and perpendicular to the line defined by y equals 1/2 x minus 4. So this line, y equals 1/2 x minus 4, has a slope of 1/2. We are supposed to be writing the equation of a line that's perpendicular to that one, so ours will have an opposite reciprocal slope. So the slope is 1/2, so the opposite reciprocal of 1/2 is negative 2. So that's our m. Y equals mx plus b. And now we just put in this point they gave us, 2, negative 3, for y and x. So negative 3 is equal to negative 2 times 2 plus b. So negative 3 plus 4 is equal to b, so b is 1. And therefore, we have y equals negative 2x plus 1. So that would be the equation of that line. And if you had a problem about parallel lines, which I'm skipping, you just need to know that they have the same slope. So you would just use the same slope if you were given the slope of a parallel line. Okay, so here is a real-life application of linear equations. A family cell phone plan costs $130 a month for 4 lines. Each additional line costs $19.99 per month. Write a linear function to model the monthly cost, C of x, in dollars, of a family plan for x additional family members added beyond the first 4. Okay, so monthly cost, C of x. So part A, C of x. This is the cost for this family plan. What do they tell us? You just pay $130 if you have 4 lines. And then every extra line is $19.99. So $19.99 times X, which is the number of extra people that are going to be on this plan. So this would be the cost of the family plan if you had X additional family members beyond the first 4. Part B, evaluate C of 3 and interpret the meaning in the context of this problem. So C of 3 means 130 plus 1999 times 3. And so if you punch that into your calculator, that is 189.97 per month. And that is just the cost for the family plan with 3 extra phones. So it's just, that's all it is. When they say interpret it, they mean just in your own words, write down words explaining what is that, what does that refer to? All right, linear cost, revenue, and profit functions. A linear cost function could model how much it costs Bob, for example, to sell lemonade at the farmer's market each Saturday. C of X is the cost to produce X cups of lemonade each week. C of X is equal to MX plus B, so it's a linear function. We have what's called the fixed cost, B, and that's a cost that does not change no matter how many cups of lemonade he makes. That's the cost like to rent the lemonade stand or the gas to put in the car so he can go to the farmer's market. Things that even if he doesn't sell one single cup of lemonade or even make 1 cup of lemonade, he's going to have to pay that if he's going to do this job. So it's a fixed cost that is not affected by the number of cups of lemonade he makes. And then you have the variable cost. This is the cost to make a cup of lemonade. So the things you need to make each cup, and that cost, that variable cost, is affected by how many cups of lemonade you make. Because for each cup of lemonade, you need a cup, you need some lemon juice, you need some sugar, you need some water, you need a straw, you need a lid, you need all those things for each and every lemonade that you sell. So the variable cost is your M. It's the one that gets multiplied by X, the number of cups of lemonade that you sell. So that's the variable cost, M. A linear revenue function models revenue. So R of X means the money that you get for selling X items. And that's just X times the price of the item. So if you sell your lemonade for $1 a cup, then your revenue is going to be $1 times the number of lemonade cups you sell, cups of lemonade. So revenue is just a function that talks about how much money you get, how much people hand Bob over the counter as he gives them their lemonade. That's his revenue. That's the money that's coming in. Price per cup times the number of cups, PX. A linear profit function models the profit for producing and selling X items. So P of X is equal to R of X minus C of X. Subtract the cost to produce X items from the revenue brought in from selling X items. So what that is saying is that he has to pay for his gas, his rent. He has to pay for all the cups and the lids and the lemon juice and the sugar. And then he gets money, the revenue is coming in. But to figure out his profit, you have to subtract the cost, the C of X, that he had to pay to do all this from his revenue, the money that people were handing to him over the counter. So that's when you find out how much money he really made, his profit. So profit is equal to revenue minus cost. Okay, so at a summer art show, a vendor sells lemonade for $2 per cup. The cost to rent the booth is $120. Furthermore, the vendor knows that lemons, sugar, and cups collectively cost 50 cents for each cup of lemonade produced. So we're going to write a linear cost function to produce X cups of lemonade. So the linear cost function, C of X, is equal to the variable cost plus the fixed cost. So mx plus b. You can think about it that way because it is a linear function. So the fixed cost is the thing that he's got to pay no matter what, and that's the rent. He has to pay that even if he doesn't sell any lemonade once he gets there. He still has to pay that 120. And then for each cup of lemonade he sells or makes, he has to pay 50 cents for the cups, the sugar, and the lemons. So that is his M. So 0.5 times the number of cups of lemonade he sells or makes will be his variable cost, 0.5x. So that is the cost function. Then part B says write a linear revenue function. The revenue function is just about how much money he gets, how much money people hand him as he's giving them lemonade. So that is $2 per cup. So 2 times the number of cups, 2x. And then part C, write a linear profit function for producing and selling X cups of lemonade. So his profit is equal to the revenue, so all the money people hand him over the counter, minus all the things he had to pay for, like the rent and the cups and the lemonade and sugar and all that. So that is the revenue function was 2x. Cost function was 0.5x plus 120. And so that is going to be 2x minus 0.5x is 1.5x, and then minus 120. So that's the profit function. Okay, how much profit will the vendor make if 50 cups of lemonade are produced and sold? So remember that profit function, we're doing D now. That profit function was $1.50 times each cup of lemonade minus the $120 of rent. And so if he makes 50 cups of lemonade, P of 50 is equal to 1.5 times 50 minus 120, and that's going to be 75 minus 120, and that is no profit. That is less than a profit. That's a loss. So he's going to be losing $45 if he only sells 50 cups of lemonade. So he needs to get on the ball if he wants to make a profit, because it's not easy to make a profit selling lemonade. He's already paid out that $120. He's paying for all those lemons and whatnot. He needs to sell more cups than that. All right, part E, how much profit will be made from producing and selling 128 cups? So that's going to be the same profit function, 1.5 times 128 minus that rent. That would be 72 whole dollars. So if he sells 128 cups of lemonade, he'll make $72 for the day. All right, determine the break-even point. The break-even point is when he doesn't make any money, but he doesn't lose any money. So that means his profit would be 0. So when you see the word break-even, that phrase, break-even point, you are looking to find out when P of X is just 0. He didn't make any money, but he didn't lose any money. He just had fun. So P of X equals 0 means that 1.5x minus 120 is equal to 0. And so if you add 120 to both sides, 1.5x equals 120. And that means that x is going to be 80. So if he sells 80 cups of lemonade, he will break even. He'll be fine. But if he sells less than that, he'll lose money. If he sells more than that, he'll make a profit. All right, and you can see this; these graphs here give us that information as well. You can see that the cost function there is graphed as the blue line on the left graph, and the revenue function is that 2x, the purple line. And so you can see at 80, that's where those two lines cross. If you have less than 80 cups of lemonade being sold, then your revenue is less than the cost. If you sell more than 80 cups of lemonade, the revenue is greater than the cost, which means you make a profit. So if you graphed the profit function, it would be this blue line on the right. It would cross the x-axis at 80. So at 80, that means the profit is 0. And then above 80, it's above 0. And below 80, it's below 0. So those are the graphic ways to look at the cost, the revenue, and the profit. All right. Example 7, the data shown in the graph represent the age and systolic blood pressure for a sample of 12 randomly selected healthy adults. Suppose that X represents the age of an adult in years and Y represents the systolic blood pressure. Use the points 21, 118 and 51, 130 to write a linear model relating Y as a function of X. So you have this graph. The X-axis is age and the Y-axis is blood pressure. And they're giving you 2 points on there. They've got a 21-year-old person with a systolic blood pressure of 118. They have a 51-year-old person with a systolic blood pressure of 130. So you want to find an equation that models this situation, how the blood pressure increases as age increases. It's not quite a linear equation. You can see those data points. Those blue dots are different people of different ages and what their blood pressure was. It's almost a line, but it doesn't really exactly fit a line. But we're going to say it's pretty close. So let's write a function that expresses that. And we can do that with the 2 points they gave us by finding the slope and the y-intercept. So we're going to write an equation y equals mx plus b. And to find m, we're going to subtract the y's over the difference in the x's. So 51 minus 21, and that's 12 over 30, which is going to be 2/5. So 2/5, y equals 2/5 x plus b, and now we can plug in a point. I'll plug in that first one, so 118 for y, and then 2/5 times 21 plus b. So that's 118. So we can just say 118 minus 2/5 times 21, and that's about 109.6. So our final equation for that would be y equals, our slope is 2/5, which is 0.4 x plus 109.6. So that would be a model of the way this works, the way the systolic blood pressure acts as you go up in age. So it's a linear progression, a linear function. All right, so that's part A. And then for part B, it says interpret the meaning of the slope in the context of this problem. Okay, remember we talked about how slope represents a rate of change. So the meaning of the slope is it is the rate of change in blood pressure for a person as they age. And then for C, use the model to estimate the systolic blood pressure for a 55-year-old, round to the nearest whole number. So we really should have written that model as a function instead of y equals. We should have said f of x equals 0.4x plus 109.6. That was our model that we made for this particular situation on the previous slide. And now we just want to find out, well, what is the blood pressure you would assume is going to be for someone 55 years old according to this model. So that would be f of 55. And we would just put that in for x. And that's 131.6. And that's millimeters of mercury, I think. And so that would be, let's see if that looks right. It does look right on this particular graph. So just means that as you age, your blood pressure goes up a bit. It's not super fast, but it starts to increase as you age.